This is your first agricultural TV station in Nigeria. My name is Joshua Isha. Welcome into the program Aqua Farming. For those of you who are tuning in for the very first time, Aqua Farming is a program that talks about everything that is in the water. And it's more reason why we try as much as possible to bring to you the best practices when it comes to aquaculture. And today on the program, we'll be looking at intelligent fish farming, the future of aquaculture in Nigeria. Like any other agricultural practices of mechanized farming and drones and their likes, aquaculture is not left behind, as there are technological way in which every process of fish farming can now be practiced, which is the future of aquaculture in Nigeria. Stay tuned and take a look.
Fishery products play a central role in food security and nutrition strategies at all levels. It is estimated that global fish production is about 179 million tons, of which 82 million tons come from aquaculture. From 1961 to 2021, the average annual growth rate of global consumption of fish for food was 3.1%, which was almost twice the average annual growth rate of consumption of fish growth rate of the world population during the same period. The rate was also higher than that of other animal protein foods, meat, dairy products, milk, with an annual growth rate of 2.1%. Fish have great potential to become an important substitute for livestock and poultry protein. The key reason for this is better quality, cheap protein present in fish, and there are no epidemic problems such as avian influenza in aquaculture. Due to the impact of restrictions on travel and entry-exit caused by COVID-19, fisheries in the world have encountered difficulties in securing migrant labor. Furthermore, the agricultural labor force engaged in fishery production is gradually entering the aging stage, and labor shortage makes it difficult to guarantee the normal supply of global aquatic products. Overfishing, backward aquaculture methods, human activities, industrial pollution, and other reasons make the aquaculture water quality worse. Aquatic ecosystem is damaged and aquatic product disease occur frequently. Several major aquaculture product areas in the world are facing the problems of tightening domestic environmental protection policies and aggravating aquatic biological diseases. Meanwhile, the suitable aquaculture zone will be reduced year by year, and the profit income per unit area is declining. The scientific and technological innovation and engineering technical support of the world fishery industry chain are insufficient. There is a lack of basic research and basic theory related to biological environment interaction and engineering process integration. The development of aquaculture engineering, mechanization, and information technology and equipment construction are seriously lagging behind. Some breeding enterprises in underdeveloped areas are restricted by breeding technology and environmental conditions. Breeding plasm is degraded. Enterprises lack good varieties in aquatic products are of low quality. The use of various antibiotics, hormones, and high residue chemical drug in aquaculture production is no longer an individual phenomenon. An irregular and unscientific use of drug has made the problem of drug residue in aquatic product become the focus of attention. Aquaculture is facing huge challenges, but there's also a bigger opportunity. Ecological facility, industrial, intelligent are the future development direction of aquaculture. In order to improve Nigerian salmon production and ensure high standard of quality, as a global leader in automation technology, is building the first new concept offshore submersible fish farm in the Arctic Ocean. The fish pens will be remotely controlled by a feed barge. Environmental data including meteorological conditions, ocean current, dissolved oxygen, water temperature, value of different water layers, and net cage. Biomass are collected by automatic equipment and uploaded to ABB ability using wireless communication. The ballast water system in fish pens can resist fierce weather and wave conditions. The whole industrial electrical system has high robustness, but it is not involved in the task of fish behavior analysis, intelligent fishing, and adult fish harvesting. Some organizations have begun to build various types of intelligent fish farm. Projects attempt to carry out inspection, maintenance, and repair operations at sea base fish farms through the cooperation between the unnamed aerial vehicle and remotely controlled underwater robots. In addition to being used as a takeoff and landing platform for aerial drones, the unnamed ship can also be used as a base station for underwater robots. The unnamed aerial vehicle is responsible for checking the integrity of surface facilities and monitoring the feeding process of fish. The underwater robot should not only complete the underwater inspection tasks, but also clean and repair the fishing net. These intelligent equipment will provide technical support for the rapid development of intelligent fish. The key technologies of the above project include the hardware design of unnamed ship, aircraft and underwater vehicle, and the software development of autonomous control system. The difficulty of this project is that these advanced technologies should work together accurately as an advanced stage of aquaculture development. Intelligent fish farm will apply intelligent machines to replace manual labor and optimize the deployment of fishery resources in a data-driven way to achieve efficient, green, and smart aquaculture. This documentary introduces the latest integrated application of edge computing and 5G technology in the construction of intelligent fish farm and puts forward the architecture of intelligent fish farm ecosystem for the first time. Then, according to the hardware of configuration of the system, the key intelligent equipment of the intelligent fish farm is listed and its technical characteristics are analyzed, aiming at the top-level design of intelligent fish farm. The lesson research status at home and abroad is summarized from the aspect of water quality, early warning and control, intelligent feed, fish behavior monitoring, biomass estimation, fish disease diagnosis, and equipment fault diagnosis under the design scheme of relevant business models of intelligent fish farm is proposed. Finally, this documentary summarizes the challenges and research hotspots in the development of intelligent fish farm and tries to provide aquaculture professionals with the latest, complete, and referential ideas about future fishery construction. This documentary analyzed that the intelligent fish farm is a well-weathered full process and full-space automated production mode that is, in the case of workers not entering the fish farm, the new generation of information technology such as IoT, big data, artificial intelligence, 5G cloud computing, and robots are used for remote measurement and control of fish farm or robots, independent control fishery facilities, equipment, machinery so as to complete all production and management operations of the fish farm. Finally, intelligent fish farms rely on digital and intelligent technology to solve the problems of aquaculture labor shortage, water pollution, high risks and low efficiency. Intelligent fish farm is the industrial transformation of fishery production mode and the development of direction of fishery in the future. Intelligent fish farm can be divided into 4 categories according to different cultures' environment: pond type intelligent fish farm, land-based factory type intelligent fish farm, cage type intelligent fish farm, and intelligent marine ranch. Pond type intelligent fish farm collects water quality information using sensors in real time and a named aerial vehicle patrol to obtain the water surface activities of fish. The growth status and feeding process of fish are observed by bionic fish. The water quality is regulated by fertilizing and spraying chemicals on unnamed boats. Bait is transported by unnamed vehicle, is accurately controlled by intelligent aeration system. The intelligent bait feeder realizes accurate and automatic feeding. Intelligent harvesting is carried out by automatic trawl machine and fish distributor. Only when all systems work together in orderly manner can reliable operations of the pond type intelligent fish farm be guaranteed. The base land factory type intelligent fish farm mainly realizes automated recirculating aquaculture. This fish farm mainly integrates micro filters, biological filters, intelligent feeding machines, aquaculture tell water purification and utilization devices, as well as advanced model and intelligent equipment technologies to construct a fish circulation 3-dimensional aquaculture model based on the deep study of the relationship between the basic requirements of aquaculture, biology, and the operation parameters of system. Scientific decision making on the optimal cultural density, appropriate water environment demand, and efficient aquaculture management strategy of benthic fish under the recycling aquaculture mode are carried out by extensively collecting production data and integrating big data analysis technology. By integrating high quality seed production and selection technologies, the fish farm establishes a supporting technology of good breeding methods suitable for circulating aquaculture and realizes the whole process of parent fish mating, egg hatching, fry cultivation, adult fish breeding, sales, and packaging. Now, let's talk about the Cage Tap Intelligent Fish Farm. The Cage Tap Intelligent Fish Farm obtains seawater quality and ocean current information using sensors and obtains fish movement and feeding information using machines, visions, and sonar. The feed batch can deliver bait accurately according to water quality, fish biomass, and feeding behavior. The underwater net is cleaned autonomously by the net washing robot. The automatic fish catching work are realized using the automatic net lifting system and the fish pump. The energy control of water quality is realized by light supplements and emergency oxygen system. The first farm is divided into floating type and fixed type to form a three-dimensional aquaculture mode according to the water layer where different aquaculture objects live. The bait, energy, and other production materials will be transported from the land-based warehouse to the breeding area by unnamed vessels. Cage Tap Intelligence Fish Farm can relieve the pressure of offshore resources and effectively solve the problem of land-based aquaculture occupying a lot of space. Intelligent marine ranches usually use high-definition surface cameras and other water robots to collect the video information of the ranch in real time, then transmit the video to the data server in the shore-based information control center using the transmission network for the purpose of biological identification, behavior analysis, biomass estimation. By installing Doppler sensors, underwater cameras, and sonars, the ranch obtained the ocean current data and the distribution of the plants and animals near artificial reefs. The ranch uses water quality monitoring buoys, weather monitoring stations, management boats, radar, and other underwater mobile monitoring equipment to realize the automated all-round monitoring of the marine ranch. Using satellite remote sensing technology, marine ranch can evaluate the fish stock viability in different space and time scales based on the interaction between microwave and sea surface. Macro scale structure, synthetic aperture, radar remote sensing technology can remotely sense ocean currents, cyclone, and other fish-related marine environment information. The feeding method in ranch can choose to use unnamed aerial vehicle to spread baits in the air or choose to use unnamed boats to close the water surface for autonomous feeding. The material supply from a marine ranch is usually transported by unmanned boats in the way of land-sea relay. Key technologies involved in intelligent fish farm are shown. In addition to the specific fishery infrastructure, the four types of intelligent fish farm all includes above: an underwater environment monitoring system, water quality and feeding control system, unmanned vehicle platform for auxiliary monitoring, control and transportation tasks, and the adult fish harvesting system. In the future, the intelligent fish farm can flexibly select hardware platforms according to different aquaculture requirements. The cooperation between equipment is done based on the Internet of Things and 5G. The precise control of equipment completely depends on the accurate circulation of intelligence algorithms. The key technology involved in the intelligent fish farm will be introduced. The traditional aquaculture system is a high integration of cloud technology and Internet Things technology. It adopts three-tier structure: device layer, network layer, and cloud service layer. The device layer is composed of sensing equipment, control equipment, and data acquisition terminal. The sensing equipment is responsible for collecting the environmental data such as pH temperature, salinity, ammonia, nitrogen, nitrate, water level, and the likes. as well as the working status of the device aquaculture video image information. The control equipment includes aerator, oxygen cone, feeder pump valve, and other aquaculture equipment. The data acquisition terminal is responsible for the upward transmission of sensor data and the reception of control instructions. The network layer generally adopt wireless networks such as Bluetooth, Wi-Fi, 3G, 4G, LoRa, NB, IoT, and other wireless transmission technologies, which is responsible for the data transmission between the device layer and cloud service layer. The cloud service layer includes cloud platform and smartphone app, which are mainly used to store and process aquaculture data and provide various aquaculture information services. Although the aquaculture system has the advantage of simple equipment access and rapid system construction, it is difficult to solve the following problems in the face of explosive growth of equipment and data due to unified upload and centralized processing of data by cloud computing model. Sensors continuously collect various sensing data, and the data is usually stable or with little change. Uploading all the data to the cloud for processing will consume a lot of network resources and cloud resources. When the network is unstable, it is possible to process data and control equipment in time. All sensors data and control data need to be transmitted using the network, and there are risks of information, eavesdropping, tampering, deception, and illegal operation of equipment. These problems will increase the cost of the IoT system, reduce stability and availability, and it's difficult to realize automatic production, especially in the application of large scale. Industrialized aquaculture, in addition, the non-standardization of sensing and control devices and their own resources limitation about computing and storage capabilities have brought certain obstacles to equipment access and linkage control. Therefore, to develop intelligent fish farm, it is necessary to study and solve the problems. With the advent of 5G network era, intelligent fish farm also has higher requirement for network performance compared with the 4G network. The capability index of the 5G network has been significantly enhanced. The delay must not be more than 1 ms. The peak data rate can reach 10 gigabytes. The connection density can reach 10 terminals, and the user experience rate can reach 100 megabytes. It is difficult for the current network architecture to meet these requirements. And now, massive amounts of IoT devices data are stored in the cloud service center, and the real-time interaction between user and the cloud center requires high-speed transmission rate, which will cause huge traffic pressure on the network in high mobility areas. For businesses with high real-time requirement, end-to-end millisecond level, low tendency is required, but it's difficult for ordinary cloud computing models to meet the above tasks. Therefore, this research introduces edge computing and 5G into the aquaculture system to improve the standardization, stability, and usability of the system. The conceptual design for intelligent fish farm is shown. Teams and cloud services are distributed, and key application basic processes control should be deployed at the edge layer. Web service or data analysis application can deploy on the network cloud communication layer and edge integrate resources and make them interoperable. The work of fishery information will produce a large number of multidimensional data. Big data technology is a kind of high-speed processing and multidimensional deep mining massive data to obtain valuable information. It includes big data acquisition, big data processing, big data storage, and big data analysis by simulating human thinking and intelligent behavior. Artificial intelligence can learn the massive information provided by the IoT and big data analysis and judge the problems. Finally, complete the decision-making tasks and realize the accurate operation of the fish farm compared with traditional technologies. AI technology focuses on the circulation, processing, analysis, prediction, and planning of problems. The IoT, edge computing, 5G, big data, and artificial intelligence complete each other and deeply integrate and provide technical support for the construction of intelligent fish farm. Traditional aquaculture basically relies on personal experience with low efficiency, high cost, and low automation. Nowadays, day-to-day tasks on fish farm facilities such as fish welfare monitoring, facility inspections, control of feed rationing, lice counting are currently conducted by several crews on board service vessels. In the future, autonomous and remotely operated systems could play a major role in conducting different tasks at fish farm facilities, being that the working conditions in aquaculture are very complicated and change frequently and sharply, particularly in marine cage culture. Intelligent equipment and robots will integrate advanced sensor, big data, and artificial intelligence so that they can effectively adapt to the complex operation environment and realize the independent operation of intelligent fish farm. They can also greatly reduce the labor intensity and cost, improve the fishery production efficiency. In addition, intelligent equipment and robots can autonomously perceive the massive data of intelligent fish farm and transmit this data to the cloud platform as a databases for big data analysis. Artificial intelligence serves intelligent equipment and robots and endows intelligent equipment and robots with intelligent brains which can learn judgment and make decisions independent in fishery production. Robot intelligence is the effective combination of information technology, machinery automation, technology. It can enable all kinds of machines to participate in the whole process of fishery production like human. In addition, intelligent equipment and robots also need the support of edge computing, machine vision, navigation, and precise control technology in order to meet the demand of machines replacing humans. Intelligent harvesting system is the last module for fish farm to complete the breeding cycle. Using the system, the breeding object will enter the market through the transportation with or without water. At present, trolling is the most efficient way of fishing. The system in intelligent fish farm use sonar, underwater camera, and net positioning instrument to achieve precision fishing. The participation of unnamed vehicles and unnamed ship in the transportation of aquatic products will greatly improve the efficiency of fishery production. This will help to achieve the goals of high efficiency and energy saving while reducing the labor intensity of fishermen. Sea cucumber catching robots uses Doppler integrated GPS integrated navigation, computer vision and mechanical servo drive technology to automatically pick sea cucumber. The navigator system of the sea cucumber catching robot is responsible for collecting the position information on the underwater robot, planning the navigation and routes, and controlling the movements of the robots. The machine vision system is responsible for collecting the sea cucumber images, reprocessing the sea cucumber images, recognizing the sea cucumber, and calculating the relative coordinates of the sea cucumber. The aquator can control the pressure pump and manipulator to pick sea cucumber. Mechanical servo drive technology to automatically pick sea cucumber. The navigator system of the sea cucumber catching robot is responsible for collecting the position information on the underwater robot, planning the navigation and routes, and controlling the movements of the robots. The machine vision system is responsible for collecting the sea cucumber images, reprocessing the sea cucumber images, recognizing the sea cucumber, and calculating the relative coordinates of the sea cucumber. The aquator can control the pressure pump and manipulator to pick sea cucumber.
Many thanks for staying with us here on your first agricultural TV station in the nation. It's been Aqua Farming. I'm sure you've learned the intelligent fish farming, the future of aquaculture in Nigeria. That is to say, in some time to come, human labor will not be needed to be able to practice aquaculture as technology is taking over every aspect of this very practice. Many thanks for staying with us. Bye for now.